Hello everybody, welcome to Unacademy, welcome to the Kreatryx channel. So in this particular video we are going to discuss about synchronous design, synchronous counter design, and why not, we will discuss about the lockout problem also. So let's take one good beautiful question and we'll be discussing this synchronous counter design. So welcome to Engineering Barfi, where you will get every single video in this short duration. You will be getting more and more information, right? Let's start. So this is about me. This is Bhima Shankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertised with the subjects of digital circuits, network analysis and microprocessors. And these are the benefits of Unacademy Plus subscription. You have more advantages like live classes, multiple batches you will be getting, and all the classes in English and Hindi, regular doubt solving sessions, weekly exams, complete test series is free for you. What not? Once you join Unacademy Plus, your experience is more enhanced, no doubt in it. And if you go for Iconic, you have a personal digital coach, study planner, performance analysis. You will be getting it based on your exam performance, and you will be getting a study material also. That is Iconic subscription. These are the prices for your Plus and subscription for a different duration. But here you can use my code. You will get 10% discount, and this is the final price after the discount. If you go for Iconic, these are the prices after the discount. Fine. So let's start the lecture. Synchronous counter design. So in this particular video, we are going to discuss the synchronous counter design. Let's start. Suppose here, let's take a question. Design a synchronous counter which counts the sequence 0, 3, 5, 6 and 0. This is the counter you want to design. That is, you need to start from 0, 5, 3, 6 and again it will come back to 0 using T flip-flops. Right. So you can design this problem using 4 states are there, 2 flip-flops also, or if you need highest count is 6110 requires 3 flip-flops also. If you make with 2 flip-flops, then what to do is in that particular case you need to take the output of the counter and convert into your required format. Converter is required. If you directly take the output of the counter from the flip-flop, you need 3 flip-flops here. Fine. So you should also check lockout occurs or not. Right. Let's move. Lockout meaning I will explain it, don't worry. Right. So for any synchronous design, this is the process. We should go. What is the process, sir? First you should take the present state, then what will be the next state required, and what are the inputs you should give according to the excitation table of the available flip-flop. So here present state, here next state, and what are the inputs you should give. So here present state contains, I am taking 3 flip-flops and designing it, Q2, Q1, Q0. You can take here all zeros to all ones. Right? And the next state is According to examiner, the sequence you need to count is 0, 3, 5, 6. For 0, next state is 3. For 3, next state is 5. 5, next state is 6. 6, next state is 0. The remaining you should take it as don't cares. Remaining you should take it as don't cares. Fine. So this is the sequence. Now fill the what we call inputs with T2, T1, T0. So how to justify T2, T1, T0 is don't care is anyway don't care. Right? Now listen here. For T flip-flop, if present state, next state both are same. If present state, next time both are same, then your input should be 0. If present state and the next state are different, you should give 1. Toggle condition is required means you should give 1 as the input. So present and the next different, give 1. Okay. Just a minute. Now, present state, next state different 1, present state, next state different 1, present state, next state same 0, present state, next state same 0, present state, next state different 1, present state, next state different 1, present state, next state different 1, different 1, same 0. Okay, fine. Is it clear? If the present and next are same, you should give 0 as the input. If they are different, you should give presently 1, next you want 0 means you should give 1 because toggle flip-flop. So you should make 3 K-maps. Right, listen here. This is T2, T1 and T0. You can say with respect to Q2, Q1, Q0. Right, done. So fill this table 0 double cross 1, next cross 0 1 cross, next 1 double cross 1 and cross 1 1 cross, next 1 double cross 0 and cross 1 0 cross. Right. So now listen please. This is one quad, one octet, one quad. So what is your T2 is Q1, what is your T1 is 1, what is your T0 is Q1. Okay, so please listen here carefully. This is what you need to make a design, Q1 1 and Q1 bar. So you can take 3 flip-flops now. This is clock, T2, Q2, Q2 bar, T1, Q1, Q1 bar, T0 and Q0, Q0 bar. Right? So please listen here. T2 is a Q1, 1 and Q1 bar. This is 1. This is a Q1. And T0 is a Q1 bar. This is how you need to design. Okay, so first part is done. How you are going to design is done. Second part is check the lockout condition. What is the meaning of lockout condition is we have designed the counter for 0, 3, 5, 6. If by chance 1, 2, 4, 7 occurs, what to do? That is what we call lockout condition checking. How to check it is, see here. You should check all unused states. Analysis. For design, I showed the process na present state, next state, and what are the inputs. For analysis, what is the process is, you should take a present state. Now, what are the inputs according to your design which is already completed? What will be the next state according to the truth table of your flip-flop? So Q2, Q1, Q0, T2, T1, T0, and again. Now listen please. T2 is this is Q1, 1, Q1 bar. Q1, 1, Q1 bar. So here you take all the unused states which we have not used. 1, 2, 4, 7. What is Q1 here? What is Q1 here? 0, 1, 0, 1. What is 1 here? What is Q1 bar is 1, 0, 1, 0. If you give here 0, 0 means previous value. 1 means toggle. Here 1 means toggle. 0 means previous value. Here 0 means previous value. 1 means toggle. Here 1 means toggle. 0 means previous value. Okay. So you can see here, originally your design is like this. 0, 3, 5, 6. Okay. But if by chance 1 occurs, it is coming to next state 2. 2 occurs, next state comes to be 4. 4 occurs, next state comes to be 7. 7 occurs, next state comes to be 1. That is, if by chance any one of the unused state occurs, it is rotating in the unused states only. It is not coming back to the used states. This kind of condition is called lockout problem. Then we need to restart the system then from any of the used states. Okay, these are the used states. This is unused states. If by luck your design is like that, by chance if it occurs also it comes back to the original state, so then no problem. Okay, but that is if after 1, if it is not 2, 3, then no issue, because it will come back to used states and it will rotate. But because of this particular design, it is happening in this case only. This is called lockout problem, and the counter is called non-self-starting. Here we need to restart the system, or this problem why it has occurred is because of the design. In the design, we have considered don't cares. Because of this don't care ka matlab is anything can happen, that anything has happened. Okay, now listen here. For example, in the flip-flop, suppose you take present state as 1. What happened in your design? You see here, present state is 1, next state we have taken anything, then you got 3 crosses we have taken. What is that for? For example, you see T2, T1, T0 for 0, 0, 1 position. 0, 0, 1 position mein it is neglected. It is included. It is included. Included means you are considered as 1 in your design. In your design, this is considered as 0. So if you write these values here, okay, so that is here, this I include, I assume it as 0. These two I include as 1s. So these don't cares are considered as 0, 1, 1. So when you give 0, 0, 1, for 0, no change. That is, you get 0. For 1, it will toggle. 0, 1 will become 1, 0. So this is the background analysis you can do. Okay, in your design only, the don't cares are considered as ones. These don't cares are considered as 0. Because of this don't cares, this problem has happened. इसका मतलब इस आपका डिजाइन में next state don't cares place में if you take any used state like 0, 3, 5, 6, if you take here any used state, this problem will not occur. Instead of taking the next state of unused as don't care, if you take any of the used states, this problem will never occur. Right? Chalo. That is how you can design what we call this one and analyze. This is analysis table. This is the design table. Design and analyze the synchronous counter. Okay, you can try the homework. I mean practice. You can design 0, 1, 2, 4, 5, 6. Okay, using JK. Okay, check lockout occurs or not. If you leave even one state also, it can form loop with itself. Okay, not like suppose you may have the doubt, sir, if 7 next state is 3, is it okay, sir? In this case, it is okay. If any one of the used unused is taken as used, is it okay, sir? In this case, it may be okay, not every time. Even you leave one single state also, that may form loop with itself. So to avoid what is the meaning of lockout in the synchronous design? If by chance, if the counter enters into any one of the unused states, it never comes back to the used state. That condition is called as lockout problem. When lockout occurs, we need to restart the system or redesign by taking the next state of all unused states into any one of the used states. Right, guys? That is how you design any synchronous system. Okay. Thank you very much. We'll meet with one more video next class. Thank you.